Okay, let's take a look at a problem. This one about an aircraft or a plane that's flying at a 30-degree angle of elevation. Okay, and the problem states that we have an aircraft climbing at a 30-degree angle to the horizontal. How fast is the aircraft gaining altitude if its speed is 500 miles per hour? Okay, so right here we know that I've got this plane. I've labeled the plane's path as h, like the hypotenuse of my triangle here. I know I've got an altitude, or the height of the plane, right here, the altitude of my triangle. Okay, so it looks like I can use the sine function and say the sine of 30 degrees equals a divided by h. And we know that the sine of 30 degrees is 1/2. Okay, from here we can use our means and extremes property and know that h is equal to 2a. Okay, so I do have an equation now relating h and a here. And again, it's one of our special triangles. But again, the problem's about related rates, so we need derivatives here. So we're going to have to take the derivatives of both sides with respect to t, as we do with all related rates. So I need the derivative of h with respect to t, and then I need the derivative of a with respect to t. So I end up with dh dt equals 2 dA dt. Well, the dh dt, they told us already, that was the speed of the aircraft, which is 500 miles per hour. So 500 has to equal 2 dA dt. So now we want to solve for dA dt. And dA dt is equal to 500 divided by 2, which is 250. Okay, and a was a linear unit in my diagram, so I want some linear unit as far as my numerator is concerned, divided by time. And again, the time, I'd want to keep the same units throughout the problem. So this is miles per hour. So dA dt is equal to 250 miles per hour. And that's the change in altitude with respect to time. And again, all related rates are with respect to time. Make sure that you're using the same units. Okay.